Assalamualaikum and a very good day class. So we meet again. In this video, we will learn how to solve or finding roots of equation by using bracketing method. If you see here, this figure 1 illustrates the basic idea of bracketing method, that is guessing an interval containing the roots of equation. For example, if you learned previously, you have learned about XL. It is actually lower value, and we have XU as upper value. So class, in this case, starting a point of the interval is a lower bound, we denote as XL, and then the interval will end with the point of XU as upper bound. By using bracketing method, the interval will split into two sub-intervals and the size of the interval is successfully reduced to a small interval. The sub-interval will be reduced the range of interval until its distance is less than the desired accuracy of the solution. Means that here, for first iteration, for example, we will start here with the interval A and B, whereas this A is XL and this B is XU. And by using bracketing method, this interval will be divided into half. When, for example, this one is divided into half, so we will have here a smaller interval. Let's say now this one become our new XL. So now for the second iteration, we will have this one as XL and this one as XU. For the first iteration, this is the size of interval, but for the second iteration, the interval will become smaller compared to the first one. And for the third iteration, again, this one will be divided into half, and maybe this one is your XL new. So here, this one we can means that for the third iteration, you have interval which is become much more smaller compared to the second iteration. The advantages of the bracketing method, it always converges to the true solution. This is the most important part, because actually sometimes when we use, for example, open method, the solution will diverge. But for the bracketing method, because we always will bracket the root. For this one, XL and XU, and we know in between these two, we have actually XR. The rule always bracket means that the solution will converge. There are two types of bracketing method. The first one we call it as bisection method, and the second one is false position method. So class, now we'll go to the first type of method, which is bisection method, and later we'll go for the false position method. For the bisection method is the simplest bracketing method. The lower value here XL and upper value XU will bracket the root. The procedure will start by finding the interval XL and XU where the solution exists. As shown here, at least one root exists based on the incremental search if the function changes its sign. Means that if fxl multiplied by fxu, you got less than 0, means that there is at least one root exists in between XL and XU. Why this happened? As mentioned previously, if, for example, here is a positive function, and then here is a negative function, when you plot this graph, of course, there is one point that will cross x-axis. When the function cross x-axis means that our function here, fx here, will equal to 0, so that in this case there is x which is fulfill this condition, so this x we call it as a root. In this case as well, we have here fxl less than 0, so this one is a negative, this one positive. So when you plot, of course it will cross, the function will cross x-axis, means that here there is x that make our function of fx equal to 0. So that this x, we call it as root of the equation. When we want to solve bisection method in the example, we'll use all the steps here. The step number 1, what you need to do is you have to choose the lower XL and upper XU that bracket the root such that the function has opposite sign. And then once you got XL and XU that make the function has opposite sign, you have to estimate the root of XR by using this formula. This formula comes from incremental search formula, which is here XL plus XU divided by 2. And then for step number 3, this is the most important part. That is, we need to use the following evaluation to identify the sub-interval that root lies. In this case, if fxl, fxr less than 0, then the root lies in the lower sub-interval. Therefore, we can set xu equal to xr and repeat step 2. But if the multiplication of fxl, fxr greater than 0, then the root lies in upper sub-interval, then we set xl equal to xr. But class, if you got here this multiplication equal to 0, then the root is equal to xr, means that we terminate the computation. Maybe this one is quite complicated or a little bit confused for you. So how to understand this? For the case number 1, for example here, we have this graph, which is we have fxl, fxr, which is less than 0. So here is xl, here is xu, and here is xr. We know that, for example, if we have fxl, here change its sign. Okay, fxl is positive. So if fxl, fxr less than 0, means that the point for function of fxr should be negative. Because this one positive, this one negative, you multiply both, means that you will have got fxl times fxr will be less than 0. So in this case, when I plot here, actually, this one is estimated root of this problem based on the graphical view. In this case, when this one fulfill understood in this interval, there is no root. In interval xr and xu, there is no root. But the root actually happen at interval xl, xr. So in this case, when you want to go to the next iteration, you can set this xr equal to xu. Now, for the next iteration, you will have your new interval instead of for the first iteration. For example, you have this xl, xu interval, but when you set this xr interval, now you will have much more smaller interval, which is xl, xu. That's why here we set xu equal to xr, then we can proceed to the next iteration. But for the second case here, for this case, if for example we have here, this one is XL and this one XR and we have XU. In this case, if you see FXL, FXR greater than 0, means that, for example, this one positive value, this one also positive value. Because this is positive, multiplied by positive, you will got greater than 0. When you plot this one, it will not cross x-axis here. But actually, it will cross, for example, here, because understood from the step number 1, fxl, fxu must be less than 0. So here, when it cross here, the root is not located in this interval, but the root is located in the second interval. In this case, you go to next iteration, you need to set this xr as xl. So you have this new interval for the next iteration. That's why for the step number 2, we need to, for the condition number 2, we need to set xl equal to xr and repeat step number 2. But if fxl, fxr equal to 0, means that here understood this is xl, this is xr, this is xu. When here it is equal to 0, means that this is your xl. If multiplication you got equal to 0, so this one should be at intersect at x-axis. So when you plot this like this, means that this one already intersect at x-axis. We said that this xr is our actual root. So we can terminate the computation. And then class, step number 4, you need to calculate the approximate percent relative error. And once you calculate this one, you have to compare with the epsilon s. Epsilon s is stopping criterion that you have learned in chapter 1. When epsilon a is less than epsilon s, then we can stop computation. Otherwise, you need to go to step number 2 and repeat the process by using the new interval. This is the algorithm. How can we solve of finding roots of equation by using bisection method, and we will apply all these steps in the next example. So class, now we go to the example that relate with the bisection method. The question asks you to use 3 iterations of the bisection method to determine the root of fx equal to negative 0.6x squared plus 2.4x plus 5.5. And then here you need to employ initial guesses of given to you xl equal to 5 and xu equal to 10. Compute the approximate percent relative error epsilon a. And then you also need to compute the true percent relative error epsilon t after each iteration. What we need to do first? We need to calculate the true value for the given quadratic function, because in this question you need to calculate the epsilon t, so you need the true value. So here, this is a quadratic equation. Quadratic equation, you can solve it by using a formula of x equal to negative b plus minus the square root of b squared minus 4ac by 2a. In this case, in our equation here, this is the value of a, this is a value of b, and this one is a value of c. So that here, this is negative b, means that negative 2.4, plus minus a square root of b, so 2.4 square minus 4, a is negative 0.6 and c is 5.5. You need to divide by 2 times a, which is 2 times negative 0.6. When we solve this one, we'll get here two solutions, which is the first one is x equal to negative 1.6286 and the second one is x equal to 5.6286. But here, look at in this question, given to us xl equal to 5 and xu equal to 10. So now, root that we need to choose based on this must be lies in these two values, in between two values here. That is, if you see here, we have this is xl equal to 5, xu equal to 10, means that root that you choose from this one should be lies in between 5 and 10. If you see here, x equal to 5.6286 actually is the true value for this problem. And then, how can we estimate the root of fx by using bisection method? If you still remember step number 1, we need to choose the lower guess xl and upper guess xu that bracket the root such that the function has opposite sign. So for the first iteration here, already given in the question that our x lies in between 5 and 10, because in the question we already have xl equal to 5 and xu equal to 10. So now what we need to do, we need to check f5 and function when x equal to 10. What are the values for these two functions? And is it the multiplication of these two functions will give us the value less than 0? In this case, to compute f5 here, we need to substitute in the equation. That is, we have our fx equal to negative 0.6x squared and then plus 2.4x plus 5.5. So in this case, when we want to compute f5, this 5, which is this is x, we need to substitute in this function. We'll have here negative 0.6 times 5 squared plus 2.4 times 5 plus 5.5. When you solve this one using your calculator, you'll got the answer 2.5. We did the same way for f10, but now x here we need to substitute with 10. And then when you substitute x with 10 for this equation and you use your calculator, you'll got negative 30.50. We can see here This one is greater than 0, so this one is less than 0. Means that F5 times F10 is less than 0, so it's guaranteed in this interval there is at least one root. So once we identify that the multiplication of both functions is less than 0, we can go to step number 2. That is step number 2. We need to find our XR by using XL plus XU divided by 2. So in our case, XL is 5 and then XU is 10, which is 5 plus 10 divided by 2, we will got 7.5. This is our estimated root. Okay. And then class, once you got this one, you need to find a function of this XR, which is function of 7.5. How to compute this? 7.5 need to substitute in this equation. So we will have here negative 0.6 times 7.5 squared plus 2.4 times 7.5 plus 5.5. When you solve this one, you will got the answer negative 10.25. And then class, for this step number 3, okay, the next step is step number 3. We need to check the sub-interval where the root lies using the evaluation. We check the multiplication of the FXL times FXR. Either it is greater than 0, or it is less than 0, or it is equal to 0. In this case, previously here we have compute FXR, F7.5. So FXL we already got from here, which is you can see this one is negative, this one is positive. Means that FXL, which is F5 with times F7.5, it is equal to here 2.5 times negative 10.25, means that you will got the answer less than 0. So the root lies, we can conclude that the root lies in the lower sub interval, because here originally we have 5 and 10 as our interval. And then we compute our XR, new XR here is 7.5, it is midpoint. And then we check this one, the function is positive. Here, the function is negative 30.5. But here, when x equal to 7.5, the function also negative, which is, for example, negative 10.25 somewhere here. So, when we plot here, you can see if in this interval, because when we go to the next iteration, our interval must become smaller. So here, we can say that if we want to choose the interval, we need to choose either the first one, either XL, XR or XR, XU. Okay, this is the second one. In this case, we need to choose the first one because here you can see FXL times FXR is less than 0, so it will cross x-axis. But FXR and FXU, it will not cross x-axis. So, in this second interval, actually there is no root. The root lies in this first interval. Means that here, we need to set our new XU, this one become XU instead of this. So this interval is no longer used. Means that you set XU equal to 7.5. And then class, you can compute here epsilon t, which is equal to the true value. True value we have calculated previously, which is 5.6286 minus current minus XR that we estimate in this iteration. So in this iteration, our XR is given by 7.5. So minus 7.5 divided by 5.6286 times 100%. When you use calculator, you will get 33.23% as the solution. But class, remember, for epsilon A at the first iteration, we are unable to compute because epsilon A is equal to epsilon A here equal to the present solution minus the previous solution divided by the present solution. But here, for the previous solution, we don't have the solution. Previous one, before we solve for the first iteration, we only have the interval. We don't have the previous XR. So we are unable to compute the epsilon A for the first iteration. Now class, we go to the second iteration. Based on first iteration, we have choose the interval instead of first we have 5 to 10 and then we make interval become smaller. That is for the first iteration you have this one as interval, but for the second one we have choose 5 to 7.5 as our interval. And in this case, F5 we have computed previously, which is equal to 2.5. F7.5 negative 10.25 means that here we understood based on previous the function is less than 0. The multiplication of these two functions is less than 0. So now class, we need to estimate our new XR using bisection method, which is XR equal to XL plus XU divided by 2. So now we have our new XL, this is our new XL, and this is our XU. And now we compute our XR. We'll got here 5 plus 7.5 divided by 2, 6.25. And then class, we compute the function of this 6.25 by substitute this 6.25 in the original equation. And then we'll got here negative 2.9375. Here, if we see our fxl here is f5, which is this one is positive function, multiply with f6.25, which is this one is negative function, and positive we multiply with negative function, we'll got now less than 0. If this one less than 0, we have here the first interval 5 to 10. And then when we do a first iteration for the second one, we have 5 to 7.5. And now we have a new XR, which is 6.25 here. So from this, we can decide our new interval, which is either it is 5 to 6.25 or 6.25 to 7.5. So now if you see, this one is positive, this one 6.25, the function is negative, and 7.5 also negative. Means that when we plot, we got something like this. But class, where actually it crossed the root, it crossed x-axis. So the function cross x-axis for the interval 5 and 6.25. That's why here the root lies in the lower subinterval. This one is lower subinterval. Then we can set here, we have our new XU. This one become, which is 6.25 will be our new XU. So if you go to the next iteration, you will have X in 5 and 6.25. What we did here, class, we made our interval become smaller and smaller. When this interval becomes smaller and smaller, it will reach finally the actual root. Okay, it will be close to the actual root. And then once we got this one, we have set XU as 6.25. So now we have to compute epsilon t. How to compute this epsilon t? We have the actual root is given by this. This is actual root. You need to minus with the XR that we obtain here. Okay, divide by the actual root multiplied by 100%, we'll got 11.04%. And then we can compute epsilon A. How to compute epsilon A here? Epsilon A equal to the current solution, which is 6.25. Okay, minus previous XR. Previous XR is 7.5 divided by the current XR 6.25 times 100%. So when you solve this one, you got 20% error. This is second iteration. But class, the question asks you to do up to third iteration. So when we go to the third iteration, actually class, you can use directly table like this. For the first column, we put here I. I means that iteration. We have first iteration. For the first iteration class, we need to put here XL and then we have XU, XR. Okay, and then we have the next one is function of XL, function of XU, and also function of XR. So the question also asks you to compute epsilon t, epsilon a. But before this, before epsilon t, epsilon a, we have to have function of xl times function of xr, because this one we need to check the condition. And then epsilon t, epsilon a. So class, for the first iteration, we have from question xl is 5, xu is 10. And then we compute XR 7.5. We also compute function for all these XL, XU, XR, whereas function of XL, which is function of 5, it is 2.5. Function of XU equal to negative 30.5. Function of XR equal to negative 10.25. And then class the multiplication of this one and function of xr, you can see here it is negative 25.625, and you compute epsilon t previously 33.25%, but epsilon a we unable to compute. And then we go to second iteration. When this one is less than 0, means that we need to set our xr equal to new xu. So here, instead of XR at this column, now it's become new XU. So we change our XU instead of 10 to 7.5. But XL remains same. And here class, we can see we already have the value of function of this 5. But we need to compute here XR, our new XR. We did previously, we got 6.25. And then its function here same, because this one the value not changed. And then for this one function of xu will be changed. It becomes negative 10.25. And then you need to compute function of this 6.25, whereas here we got negative 2.9375. And when this function 2.5 multiplied with negative 2.9375, we'll got here the answer negative 7.3438, which is here it is less than 0. And then we will compute area. Previously we got 10.04 for epsilon t, and epsilon a it is 20%. And then class, we go to third iteration because the question asks us to do up to third iteration. So when we did for third iteration here, you see this one is t less than 0. When this one less than 0, we have here 5 and then 6.25, and then we have here 7.5, means that this positive, this negative, this negative. So if I plot here, the root lies in the first sub-interval. So we set for the next one, our XL is 5, but our XU become 6.25. And then we need to compute new XR here, which is by using formula XR equal to 5 plus 7.25. Remember XL plus XU divided by 2. So all this divided by 2. We'll got the answer here equal to 5.625. So we'll got here 5.625. And of course, function of this 5 same, 2.5. Function of xu for this one become function of 6.25, which is this one. We got negative 2.9375. And then you need to compute function of 5.625. When you compute, we'll got the answer here 0.0156. Means that when we multiply this both, we got 0.06 that is greater than 0. This one less than 0, this one also less than 0, but this one is greater than 0. So here we compute epsilon t. Epsilon t equal to the true root, okay, which is the true root is 5.6286 minus this XR 5.625 divided by 5.625, which is times 100%. We'll got here the answer 0.06. So this one becomes 0.06. And then we can compute epsilon A using formula. The current solution, this one, minus previous. So minus this one, which is 5.625 minus 6.25 divided by 5.625 and then times 100%. We'll got here the answer equal to 11.11%. So this one is like 11.11%. So class, it comes to the end of finding roots by using bisection method. Next, we'll go to the second bracketing method, which is to solve the same problem by using bracketing method, but now we improve the method. Instead of we have a formula which is just divided by 2, here you will have more complicated formula, and that method we call it as postposition method. Thank you class, see you in the next video.